So module one, we were really focused on digital fabrication for kids. And now we're moving towards the middle. So digital fabrication with kids is where we'll be here in module two and actually throughout the rest of this program. So, flashing back to where we just finished our field activity, the digital fabrication for kids is really focuses on what are the kids learning with the tools that we're giving them, and the tools being that physical teaching aid or a kit, as we saw earlier. Manipulative can be used as part of the class infrastructure or student management or organization, but more opportunities for learning happen when that physical teaching aid is about the content that the students are learning, like that respiratory puzzle, having to put it in the right order and understanding which systems go where, and what they support is really about the content of what those students are learning. And then what we talked about, or what our guest speaker talked about, Dr. Greenstein, a few weeks ago, was really when teachers make those models and they create those for their students, they're also learning in the design process. So as a teacher in a teacher professional development program, you yourself are learning about your content while you're designing your physical aid for other kids to use. Same with the students. I just said a minute ago that learning happens in the design phase. That happened with teachers when they're developing physical teaching aids as well. So now moving to a little bit further along the curriculum, or the continuum, sorry, and think about digital fabrication with kids. Where can your kids participate in the making and the creation using digital fabrication tools? What is appropriate for your learners? What's their zone of proximal learning, as Vygotsky would say in like social learning theory, which we also talked about in module one. So in digital fabrication with kids, the students will participate in some of the creation phases, maybe the whole phase, maybe just parts of it. Really depends on, again, where your students are, where their proximal learning zone is. So the process and the design is integrated within the educational activities. And really the students get more agency in the project itself, which increases engagement. They really enjoy it when they have some agency in their design, or they have agency in running the machine. Kids get very excited when they get to press the go on the laser cutter and stand there and watch it cut for 3 minutes. They like that kind of stuff. And the more that they can be engaged in that, maybe they're setting up their own material on the laser and then they're pressing go. Maybe they're doing the whole thing from nuts to bolts. They're doing the design, they're sending it to the laser cutter. Maybe they're doing that. It really depends on where your kids are technologically and what your learning goals are for the lesson. You can skip the kids don't have to be involved in all of the design process or all of the creation process in order to feel that agency that comes along with using digital fabrication with kids and in support of learning. So how I said earlier, really learning through design is what's happening in digital fabrication with kids. The true learning and making comes from the choices and decisions that students make during the design process itself. This is researched in basically STEM subjects, specifically science and mathematics. There's some research out there about this specific learning. So their problem solving, those design choices are for a specific reason, and they need to critically think about each decision shapes, what's its functionality, why it's there. They take more ownership of the project when they make their own design choices. And they have to explain their design choices, specifically if you're doing a project-based learning unit. In their presentation, they really should talk about why they made those design choices. And again, this is all the learning. 3D printing it and putting it together is fun, but not necessarily where the glorious learning happens. And then reflection, of course, I was just speaking about. But in this picture right here, this is a 3D printed model of an atom. But you see the screenshot, they designed it on Tinkercad. So she had to decide how many electrons went on which ring, how many rings there were. And in the middle, you can see that there's the atom. This is what I know about science. Whatever atom that is, it's labeled on the thing. And it came printed out. This took an hour to print, and there's no learning happening while it's printing. And there's really not much learning happening when they're putting it together. But that design of that thing on Tinkercad took a long time, and that's where the real learning happened. So in the classroom, specifically with 3D printing, spending time with your students in that design phase is so important, and really more important than printing everything out. Often teachers will say, we'll print out one or two, but we won't print out the whole class's worth of designs, because again, the point of the lesson is learning about atoms or learning about whatever it is that you're designing, not necessarily printing it and taking it home. Although that really helps engage the students. They love when they've designed something and printed it out. So it's kind of a balance where your students are ready, how much time you have in preparation, how much time you have in the classroom, and whether or not you want to stay after school and print everybody's atoms for the next 5 days. So talking more about digital fabrication with kids, this is really where we talk about learning through digital fabrication and not learning about digital fabrication or learning to digitally fabricate. There's so much potential for digital fabrication, and specifically learning in the design phase. And again, it's supported by the science of learning, constructionism, that we talked quite a bit about. So digital fabrication with kids is really student-centered learning. I mean, there's no getting around that. It also supports project-based learning and design-based learning in a way that is really nice. It's a really good way to kind of add a technical element to a typical project-based learning, and really, as I like to say, put the T in STEM. So a lot of different things is how students can participate. They can help design their own projects and create them. They can invent their own projects, but they can pretty hands-on with the design, with the technology, depending on where they are developmentally. But most importantly, these projects reflect their learning, which really underlines that constructionist theory. It could solve and should solve a real-world problem and have a connection, which is important. And each project is unique to that student or group. Specifically, when you're doing a project-based learning, that would be a group. So they really do take ownership in the specificity of their project. There's a lot more potential than what we're seeing in Fab Labs and project-based learning. But when you're talking, when you're planning your lessons or you're talking to your administrators, really thinking about ways to use digital fabrication in project-based learning, it is pretty straightforward. I mean, not straightforward, but it's the connection is fairly obvious. All of these projects all of this project-based learning through digital fabrication can support and should support non-technical learning outcomes. Project-based learning is about more than one content area anyway. So if your content area is technology, what is your project-based learning unit going to be about? It really can't be centered on technology. Let's bring in those other content members, other content areas, and think about what are the kids learning by doing this particular project. It can be integrated into most projects for classrooms. It just kicks it up a notch from when they build stuff with cardboard and tape. Taking it to the laser cutter is really just, sticking the T in STEM. It can make learning accessible for more kids. That hands-on part, that individualized learning part, they really appreciate. And increased understanding of content and of technology. I mean, although you're not teaching kids to use a digital fabrication tool just for the joy of doing it, they will learn that. Maybe they're learning about circuits, or they're learning about the respiratory system, but they also have to kind of do this stuff to learn that. So we're not saying that learning technological learning outcomes are not valid, because they're very important, but they are kind of subsidiary to what our learning objectives should be focused on, specifically in a project-based learning situation or a design-based learning situation. And speaking of learning outcomes or objectives, or goals, as we call them sometimes. So here's some of the things to think about when you're doing digital fabrication with kids, specifically a student-centered methodology like project or design-based learning. They obviously will learn about digital fabrication processes. They will learn some soft horizontal skills, 21st century skills. SEL, we talked a little bit about. You can really integrate social emotional learning competencies into your lessons as well. When students are working by themselves or with a group, there's a lot of that social emotional learning competencies that they are practicing. And kind of picking those out and making them clear to the students could be something you could do. And then the hard skills and knowledge that comes from the content that's embedded into that project-based learning. Again, what content areas are we bringing to the table with this lesson? science, history, art, mathematics concepts. They can all be taught with using digital fabrication as a methodology embedded in project or problem-based learning. So in the Finnish national curriculum, all these kind of soft skills that Yvonne, I think Yvonne shared this. This is the national these are involved in the national curriculum for K-12 education in Finland. We have similar things in the States, depending on which state you are and which district you are in the state. We're kind of all over the map. But a lot of states are adopting, and a lot of countries are adopting standards or curriculums that support these types of non-technical learning objectives, thinking and learning to learn, cultural competence, interaction, and self-expression, taking care of oneself and others, managing daily life. This also sounds a little bit like social emotional learning. Definitely sounds like the soft skills and the non-technical content that every kid can learn while they're participating in a digital fabrication activity. Multiliteracy, competence in information and communication technology. Again, that technology is important to be in there. Working life competence and entrepreneurship, participation, involvement in building a sustainable future. Like I said, this is the Finnish version, but we have a lot of different versions that we can choose from, and you can even find non-technical competencies in any aspect of your project just by kind of seeing what's out there, but also just seeing what your kids are doing. You know, are they taking turns? Are they following directions? Are they standing in line? Are they being safety? Are they being safe? Those are other non-technological learning concepts that are pretty important, specifically like the safety one. You know, are they standing too close to the laser? Are they leaving the laser on when it's cutting cardboard and walking away? So those types of things as well. Not necessarily technical, but still important. Here are some pictures of kids involved in different aspects of the design process. Again, you'll see them mostly on computers. When students are participating in digital fabrication, there's a lot of computer work, to be honest. And you know, here we have soldering and making a circuit. So that's a really good way for students to engage with digital fabrication, is designing circuits and circuit boards. Ooh, here's another picture. Here are some more here are some more, I can't think of the word, demonstrations of learning with kids, and these will be in the presentation. You can link and see the lesson plans involved with them. But if you can see, they're all over the place with what the content is. Even just looking at the pictures, you can kind of guess the content that the students are learning by putting these together, or designing them, or putting them together, or designing and making them, or designing, or you know, helping with the design process. So wherever their participation is in this process, they're learning something.